Let us look at proposition number 3 of On the Sphere and Cylinder, book 1 of Archimedes. The proposition says, given two unequal magnitudes and a circle, it is possible to inscribe a polygon in the circle and to describe another about it, so that the side of the circumscribed polygon may have to the side of the inscribed polygon a ratio less than that of the greater magnitude to the less. So here two magnitudes have been given which have some ratio. What the proposition is saying is that it is possible to construct, or rather inscribe, a polygon in the circle and circumscribe a polygon on the circle such that the side of the circumscribed polygon has to the side of the inscribed polygon a ratio less than the ratio between A and B. So let's see how we can do that. Let A and B be the two magnitudes. Let A be greater than B. Now find two straight lines F and KL where F is greater than KL such that F is to KL is less than A is to B. And how to do this we have seen in the previous proposition. So I'm going to just bring it up on the screen. So F is this and KL is this. So here F is to KL is less than A is to B. Now in the previous proposition we were drawing it on the same line, these two. But here we are keeping it separate. Now draw LM perpendicular to KL such that KM equal to F. So we have drawn a line perpendicular to KL, but now we want a point on this perpendicular line M such that KM is equal to F. So we draw a circle with center at K and radius as F, and we take the intersection of this circle and this line and mark it as M. So now Km is equal to F. Now in the given circle, let CE and DG be the diameters so that they are perpendicular to each other. The intersection of these two diameters would be the center. Bisect angle DOC at N and join NO. So N and join NO. Repeatedly bisect one of the bisected angles till the bisected angle becomes less than 2 times KLM. This is the angle. Twice of this should be greater than the bisected angle, or bisected angle should be less than twice the angle LKM. Now here angle NOC is such an angle. Again bisect NOC and join OP. So if we take the point P and join OP, then we have bisected this angle NOC. Join NC, mark the intersection of NC with OP as H. So now angle NOC is less than 2 times LKM, which implies that angle HOC is less than angle LKM. Let OP be the radius of the circle bisecting the angle NOC. So OP is perpendicular to NC at H, and HN is equal to HC. Let tangent at P meet OC and ON extended. So let's extend this, and let's draw the tangent so that this tangent meets ON and OC at S and T. So now let's get rid of these lines. Angle OHC and angle KLM, they are both right angles, which means MK is to LK is greater than OC is to OH. MK is to LK is greater than OP is to OH. Why? Because OP is equal to OC. So ST is to CN, ST is to CN is less than MK is to LK, because the triangles CON and SOT, they are similar, which means that they are the heights are proportional to their bases, or we can say the bases are proportional to their heights. So here ST and CN are the bases and OP and OH are the heights. So we can say ST is to CN is less than MK is to LK. So that means ST is to CN is less than F is to KN. So therefore, ST is to CN is less than A is to B, because F is to KL is less than A is to B, and ST is to CN is less than F is to KL. That means ST is to CN is much lesser than A is to B, or we can just say is less than A is to B, which is what we had to prove, that the ratio between the side of the circumscribed polygon with the side of the inscribed polygon is less than the ratio between the given magnitudes. And these are the sides of the polygon. Let's confirm that. So this is the inscribed polygon with the side as CN. And this is the circumscribed polygon with ST as the side. So that is proposition number 3 of On the Sphere and Cylinder, book 1 of Archimedes works. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.